The James Webb Space Telescope has essentially sent Earth a huge exhortation, and it's moving closer. This alert comes from the exoplanet Proxima B. With each new picture sent back, extra requests arise, leaving subject matter experts terrified. Every portrayal from this distant planet makes us marvel more about the mysteries of the universe. Is it arising to foster questions about a potential unfriendly planet near Earth? Could there be a bordering, untouchable planet with opposing objectives? Could Proxima B ever pose a threat to our very existence? The subject of alien life has intrigued humankind for many years. Be that as it may, with present-day advancements like the James Webb Space Telescope, it has become a question we can investigate more thoroughly than ever before. Yet, the universe isn't making it easy to find answers. We continue to use our best tools, for instance, the James Webb Telescope, to glimpse distant planetary systems, hoping to find hints that might indicate life beyond Earth. However, we must remain cautious. Each new picture and piece of data reminds us how little we truly know. While these revelations could be earth-shattering, they also highlight the vastness and complexity of the universe, leaving us with more questions than answers. Sorting out a far-off planet like Proxima B could redefine our place in the universe. For specialists in space science, this is exciting, but for the general population, it often feels like just another piece of distant space news, far away, abstract, and at times overwhelming. These discoveries raise more unexpected questions than they answer, prompting many to wonder how this affects life on Earth. Could Proxima B truly harbor life, or even intelligent life that might one day pose a risk to us? Despite the immense power of the James Webb Space Telescope, it can only reveal so much. Certainly, we've learned a few incredible things, like the fact that we now have stunning new pictures of Proxima B and the realization that the universe is far greater than we ever imagined. But what comes next? The implications of these discoveries feel as immense as the universe itself. Proxima B, discovered in 2013 due to its gravitational association with its star, was a significant scientific breakthrough. Finding this exoplanet was like discovering a new neighbor. Proxima B is potentially slightly larger than Earth and orbits its star predictably, making it an intriguing subject for further examination. From a scientific perspective, the prospect of another world so close to our own is exciting. Yet, for most people, it's challenging to connect with a place that is 25 light-years away. To put that into perspective, even the fastest spacecraft humans have ever built would take several centuries to reach it. Imagine what it might be like to stand on Proxima B. Its star, Proxima Centauri, would appear as a faint red light in the sky, much cooler and dimmer than our Sun. Proxima B rotates so quickly that a year there lasts just over 7 days. One side of the planet always faces the star, experiencing perpetual daylight, while the other side remains in constant darkness. It sounds like something out of a science fiction novel, but reality would be far harsher. On the bright side of Proxima B, any water would likely vaporize due to constant heat exposure, while on the dark side, water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a calm or stable neighbor like our Sun. It emits dangerous flares and intense radiation, making Proxima B's surface a hazardous place for life. This is hardly the kind of environment where humans would want to settle. However, the search for life beyond Earth reached a peak in late 2020 when researchers detected an unusual signal from the Alpha Centauri system, where Proxima Centauri is located. This signal had a unique frequency of 982.551 MHz, capturing everyone's attention. Such a signal could, in theory, indicate advanced technology. However, it is still too early to draw conclusions. More recently, the James Webb Space Telescope has added to the excitement by suggesting that Proxima B might have water vapor in its atmosphere. Water, as we know, is a critical component for life, and its presence could be a game-changer. To better understand how much water exists on Proxima B, researchers are using advanced techniques like spectroscopy. This method allows them to identify the gases surrounding the planet, acting as a cutting-edge analytical tool. By analyzing the planet's light spectrum, scientists can detect specific gases like oxygen, methane, and carbon dioxide, key ingredients for life. Atmospheric modeling is another essential tool. By using virtual simulations of Proxima B's atmosphere, researchers can estimate its conditions. These models serve a similar purpose to how scientists use dinosaur fossils to hypothesize what dinosaurs looked like. The more we learn about Proxima B's atmosphere, the more we are reminded of Earth's unique biodiversity. Extremophiles, for instance, are tiny organisms that can survive in extreme conditions, such as boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These adaptable creatures show us how life can thrive under seemingly impossible conditions. The more we explore Proxima B, the more we realize how little we know about the possibilities for life in the universe. Could intelligent civilizations exist in conditions completely alien to what we experience on Earth? If so, how would they communicate? Would their technology and methods be so advanced or so fundamentally different that we wouldn't even recognize them as life forms? Such questions spark both scientific and philosophical debates. The discovery of life, even in its simplest form, would have profound implications for humanity. It would challenge long-standing beliefs about our uniqueness and force us to reconsider our role in the cosmos. While scientists are meticulously analyzing data, public imagination is running wild with theories of alien contact, interstellar diplomacy, and even potential threats. Hollywood often paints extraterrestrial life in extremes, either as friendly beings eager to share wisdom or as hostile invaders bent on conquest. But reality is likely to be far more nuanced, with complexities we can't yet fathom. Even without direct evidence of life, the exploration of Proxima B has already deepened our understanding of planetary systems. We've learned more about the dynamics of red dwarf stars and the challenges planets face in their orbits. This knowledge, in turn, informs our search for other potentially habitable planets in the universe. The search for life on Proxima B also underscores the importance of international collaboration in science. Space exploration requires immense resources, expertise, and innovation, which no single nation can achieve alone. Projects like the James Webb Space Telescope are shining examples of what humanity can accomplish when we work together toward a common goal. However, as we look outward, we must also reflect inward. The study of exoplanets like Proxima B reminds us of the fragility of our own planet. Earth is uniquely suited to support life as we know it. Yet we continue to face challenges such as climate change, pollution, and habitat destruction. In many ways, the search for life beyond Earth mirrors our search for meaning and purpose. What drives us to explore the unknown? Is it curiosity, the desire for connection, or the hope that we are not alone? Perhaps it's all of these. The journey to Proxima B and beyond is still in its infancy. Each discovery brings us closer to answers while opening the door to even more questions. As we continue to push the boundaries of science and technology, one thing is certain. The quest to understand our place in the universe will remain a defining feature of humanity. Life on Proxima B presents titanic challenges, not simply in the realm of space travel, but also in proving that life could exist in such a hostile environment. The planet is bombarded by extreme space radiation, and its atmosphere probably won't offer much protection. Moreover, the distances involved are so vast that new types of propulsion systems are necessary to make space travel to Proxima B possible. Ideas like solar sails, particle drives, and even more theoretical concepts like warp drives offer exciting possibilities for future exploration. However, these advancements are still in their infancy and require extensive research before they can be used in real missions. While dreaming about future space travel is exciting, we need to remain realistic. Finding life on Proxima B is fraught with technological and scientific challenges. Only by advancing our technology and expanding our understanding of the universe can we hope to unlock the potential of distant worlds like Proxima B. This pursuit isn't just about satisfying curiosity. It's about pushing the limits of human achievement. Could we one day set foot on Proxima B or even interact with life there? As we contemplate the long journey to Proxima Centauri, finding extraterrestrial life no longer feels confined to the realm of science fiction, but instead seems like a genuine, tangible possibility. This fascinating shift from a distant dream to a scientific endeavor has drawn serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are dedicating immense resources to transform what would normally be an extraordinarily long journey, one that could take several centuries using today's technology, into a mission achievable within decades. The goal of reaching another star system within a human lifetime has ignited innovation and optimism in the academic community. However, these grand ambitions are tempered by the stark realities of our current technological limitations. Despite remarkable advancements in space exploration, traveling to Proxima Centauri, even at just 4.2 light-years away, still presents overwhelming challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey feasible within any reasonable time frame. Breakthrough Starshot, one of the most ambitious projects, envisions using powerful laser-driven sails to propel small spacecraft to speeds of up to 20% of the speed of light. While this concept shows promise, it remains in the experimental stage and requires overcoming numerous technological and logistical obstacles, such as mitigating damage from space debris and ensuring reliable long-distance communication. While the dream of reaching Proxima Centauri and potentially discovering alien life is closer to reality than ever before, it remains grounded by the limits of current technology. Accelerating a spacecraft to near-light speeds with today's tools feels almost impossible, akin to solving a difficult puzzle in the dark. Even ambitious projects like Starshot, which aims to propel a craft toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere causes disturbances for the lasers, making it difficult for space exploration instruments to operate with the required precision. One proposed solution is the use of adaptive optics, smaller lasers on satellites that continuously monitor and adjust for atmospheric disturbances. This system would help powerful ground-based lasers stay focused on spacecraft as they travel through space. However, the laser propulsion method demands an enormous amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a limited time. Imagine setting up 100 million lasers over a vast area just to push a small spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still take 22 years to reach the Alpha Centauri system, a time span longer than many people's lifetimes. Nevertheless, the challenge of reaching Alpha Centauri isn't solely about overcoming technical obstacles. There are natural barriers as well. The gravity of the sun, the presence of space debris, and the sheer enormity of the distance involved all pose critical risks. Even communicating with a spacecraft en route to Proxima B would require sending messages across time. It would take at least 4 years for a signal to reach it from Earth. Despite these overwhelming challenges, the desire to explore other star systems continues to grow, driven by humanity's long-standing love for discovery and exploration rather than practical necessity. Even robust projects like Starshot, which aims to launch a spacecraft toward Alpha Centauri using lasers, face numerous practical difficulties. Nonetheless, overcoming these issues could transform space exploration. Still, the potential risks involved, including communication delays and natural hazards, require serious planning. Despite the difficulties, many researchers believe that the rewards far outweigh the risks. In essence, the possibility of reaching Proxima Centauri or discovering life elsewhere in the universe is something that could one day become a reality, but in the distant future. For now, we must focus on improving our space technology, studying our neighboring planets, and finding new ways to make these complex journeys possible. The pursuit of interstellar travel is not only a testament to human ambition, but also a reflection of our innate curiosity about the universe. By pushing the boundaries of what is possible, we are not only striving to answer the age-old question of whether we are alone in the cosmos, but also expanding the scope of human achievement. For now, our efforts must remain grounded in practicality. Advancements in propulsion systems, radiation shielding, and long-term life support are critical steps in paving the way for interstellar missions. These technologies, while focused on distant star systems, will undoubtedly have applications closer to home, revolutionizing how we approach space exploration within our solar system. In the near term, missions to neighboring planets such as Mars and the moons of Jupiter and Saturn offer more immediate opportunities for exploration and discovery. These endeavors can serve as stepping stones, allowing scientists and engineers to test technologies that may one day enable interstellar travel. Moreover, the search for extraterrestrial life is not limited to distant exoplanets. Efforts like the study of extremophiles on Earth and the analysis of potentially habitable environments in our solar system, such as Europa or Enceladus, could provide invaluable insights into the conditions necessary for life to thrive. Interstellar exploration also raises profound philosophical and ethical questions. If we do discover life on Proxima B or any other distant world, how should we approach it? Should we attempt to communicate? Or would such contact pose risks to either party? What responsibility do we have as explorers to preserve and protect the environments we encounter? These questions require careful consideration, as our actions could have consequences far beyond what we can currently foresee. The concept of planetary protection, which aims to prevent contamination of both Earth and extraterrestrial ecosystems, will become increasingly important as we extend our reach into the cosmos. While the journey to Proxima B or any other star system may be centuries away, the groundwork we lay today will shape the future of space exploration. Collaborative efforts between nations, private companies, and scientific institutions will be essential to overcome the immense challenges involved. In the end, the pursuit of interstellar travel is not just about reaching distant worlds. It is a journey of self-discovery, a quest to understand our place in the universe. The challenges are daunting, but the potential rewards, scientific, cultural, and existential, are beyond measure.